In this lesson, you'll lock down the wireless facts the CCNA loves to test, from channels 1, 6, and 11 to Wi-Fi 5 versus Wi-Fi 6, CAPWAP ports, and why WPA3 matters. Wi-Fi is just data riding on radio frequency energy. So once you understand how signals move through space, wireless starts feeling a lot less mysterious. As that signal travels, path loss weakens it, interference competes with it, and multipath can bounce copies of the same signal around the room. That's why OFDM matters. It splits data across many smaller subcarriers, which makes transmission more efficient and more resilient in real environments. In 2.4 GHz, channels overlap heavily, so most of them interfere with their neighbors instead of staying cleanly separated. For the exam, remember the safe trio. Channels 1, 6, and 11 are the non-overlapping choices you'll see again and again. This band usually reaches farther than 5 GHz, but it's also more crowded because so many devices live there. Move up to 5 GHz and you get many more non-overlapping channels, which usually means less interference and a cleaner RF environment. The trade-off is range. Higher frequencies attenuate faster, so 5 GHz often delivers less coverage than 2.4 GHz. It also supports channel bonding at 40, 80, and even 160 MHz, which can boost speed but consumes more spectrum. The 802.11 family evolved from early legacy wireless into faster standards like A, B, G, N, AC, and now AX, each adding better performance and efficiency. For naming, remember that 802.11 AC is Wi-Fi 5 and 802.11 AX is Wi-Fi 6. That's one of the easiest exam wins in this whole topic. Wi-Fi 5 focuses on high throughput in 5 GHz, while Wi-Fi 6 improves efficiency, capacity, and client handling across dense environments. If you remember one big theme, it's this: newer standards are not just faster, they're smarter about sharing the air. MIMO uses multiple antennas to send and receive more than one spatial stream, which can raise throughput without needing extra spectrum. Beamforming then focuses energy toward a client instead of spraying it evenly everywhere, which can improve signal quality. MIMO and OFDMA matter because they help an access point serve multiple devices more efficiently, especially in busy networks. An autonomous access point is configured and managed on its own, which works for small setups but becomes painful at scale. A lightweight access point depends on a wireless LAN controller, which centralizes policy, RF management, and configuration. That centralized model makes roaming smoother because multiple access points can behave like one coordinated system. It also enables zero-touch provisioning, so new access points can join, download their settings, and start working much faster. CAPWAP is the protocol lightweight access points used to communicate with a controller, replacing older vendor-specific approaches with a standard model. For the exam, lock in these UDP ports. CAPWAP control uses 5246, and CAPWAP data uses 5247. Control traffic can be protected with DTLS, and in Flex Connect deployments, an access point can keep serving local users even with central control in the design. When a lightweight access point boots up, it first gets basic network information like an IP address, usually through DHCP. Then it looks for a controller through local discovery, DHCP option 43, DNS lookup, or a stored controller address. Once it finds the controller, it joins, builds the CAPWAP relationship, and downloads configuration so it can operate with the right settings. Wireless security started with WEAPs, but WEP is considered broken because its encryption design can be cracked far too easily. EPA improved things, and WPA2 became the long-standing mainstream standard in real networks for many years. Now, WPA3 represents the stronger modern option, especially where better protection against password attacks matters. On the exam, think of the progression as broken, common, and stronger. That's WEP, WPA2, and WPA3. The weakness with WPA2 PSK is that an attacker can capture the handshake and attempt offline password guessing later. WPA3 uses SAE, the simultaneous authentication of equals process, which makes those offline dictionary attacks much harder. It also brings forward secrecy, which means compromising one key later should not expose older captured traffic. In 802.1x, the supplicant is the client device, the authenticator is usually the switch or access point, and the authentication server is often Radius. Those three roles are a must-know memory set for the CCNA, so make sure you can identify each one instantly. For methods, EAP is the framework, while EAP-TLS uses certificates, and PEEP commonly protects credential exchange inside a tunnel. At a high level, the client requests access, the authenticator relays the conversation, and the server decides whether the client gets on the network. For a fast review, anchor 2.4 GHz to channels 1, 6, and 11, Wi-Fi 5 to 802.11 AC, and Wi-Fi 6 to 802.11 AX. Then lock in CAPWAP control on 5246, data on 5247, WPA3 with SAE, and 802.1x as supplicant, authenticator, and server. If these wireless topics felt clearer, keep the momentum going and review them once more until those exam facts come back instantly. In the next lesson, we'll build on this foundation with automation, SDN, REST APIs, and Ensemble. So stay with the series and keep leveling up.